Hello, in this video we're going to look at substituting variables to solve quadratic equations. So this is targeted at a very specific kind of question and it can pop up on exams, so it's a very particular skill, a very set routine that we're going to go through. And I've got two examples here, so we'll start with solve e to the 2x plus 3e to the x equals 40. So solve for x here. How are we going to solve for x? Well, there's two different x's and one's a 2x and one's an x. It's clearly going to be tricky if you just try to transpose it. What should jump out at you though is that it's a quadratic form. So I'll show you what I mean. Let's transpose the equation and make it look like a quadratic. So the first thing I'm going to do is get everything on one side. So I've got e to the 2x plus 3e to the x minus 40 equals 0. And the next thing is to rewrite this part. So I'm going to rewrite it as e to the x all squared. This is the same because of index laws. Plus 3e to the x minus 40 equals 0. So what should kind of jump out at you is that it's something squared plus 3 times something minus 40 equals 0. This looks like a quadratic now. And let's make it really obviously a quadratic by substituting a variable. And the way we do that is we let a letter like a equal e to the x. So we substitute that in, we get a squared plus 3a minus 40 equals 0. Now we can solve this like a regular quadratic. So we're looking for two numbers that multiply to give negative 40 but add to give 3. Alright, what could those numbers be? Let's see. Well, 20 and 2, no. 10 and 4, no. 8 and 5, maybe. Maybe plus 8 and minus 5 equals 0. Let's check that. 8 times negative 5 is negative 40. 8 minus 5 is 3. So that means a equals negative 8 or a equals 5. But we made a substitution earlier, so we need to back substitute. We need to say, well, a equals e to the x. So e to the x equals negative 8 or e to the x equals 5. Now this one is absolutely impossible because this is a positive number to a power that can never give a negative answer. If you're unsure about that, think of the graph of y equals e to the x. It goes like that. It doesn't give a negative answer. This is the graph of y equals e to the x. So we know that that can't happen, so we have to reject that. But over here we have to solve for x. And the way we do that is with our log laws. So x equals the natural log of 5. And that's our answer. The natural log of 5 satisfies this equation. Don't believe me, let's check it on CAS. So we go menu, 3, 1, let's solve this. E to the 2x oh, it's done that glitch again. Alright, I've got to reload it. I need some loading music. Let's see, where's it gone off to? No, not sure where it's gone off to. Okay, you're going to have to trust me on that one or check it yourself. Let's have a look at another example. Let's try solving. Let's solve 2e to the 2x plus 9e to the x minus 5 equals 0. Now this one is a bit trickier, but we still use the same technique. We make it look like a quadratic. So we go 2e to the x squared. Oh, my tablet's being glitchy. 2e to the x all squared plus 9, don't know why it's doing that, 9e to the x minus 5 equals 0. Okay, now we have to do the substitution. So let's let a equal e to the x. So a is going to replace each e to the x. So we get 2a squared plus 9a minus 5 equals 0. Now we have a quadratic to solve. And this is what you should practice a lot to get really confident at, especially these non-monic quadratics. So the ones with the coefficient on the leading term are particularly salient on exams. They really like to sneak them in there. So you should get confident with these. Let's have a look. So it's going to be, well, it's going to have to be 2a or a. I'm going to use the cross method here. Let's try negative 5 and 1. So these multiply to give negative 5. These multiply to give 2a squared. Let's see if we get the middle term. This is minus 10a plus a, which is minus 9a. So that doesn't work. Let's try negative 1 and 5. This is 10a minus a, which is 9a. So that works. Okay, so the answer here is 2a minus 1, a plus 5. You can see how I've read that off there. 2a minus 1, a plus 5 equals 0. If you want more practice with that, Google non-monic quadratic examples. Find some problems on it, get some practice with it. Okay, now we can solve for a. So a equals a half, or a equals negative 5. So just like before, we have to reject the negative root, and we have to substitute in again. So a equals e to the x, so that can go down there. E to the x equals a half, so x equals the natural log of 1/2, which is also equal to negative the natural log of 2. If you're unsure about that step, look up your index laws, or you can watch this green writing, how I got from there to there. The natural log of a half equals the natural log 2 to the negative 1, and because it's a logarithm, you can take the negative out the front. That's another way it occurs. So that's your answer there. Check it with Kaz. So if you get a decimal answer, that's about 0.693. Not sure what that one is. It would be around 2. It would be something around 2 if you want to check that with your Kaz. And if you have been, thanks for watching.